Okay, this is the P3 paper from June 2021. It's question number 7, and it's going to be differentiation of trig functions here. And later on, when we're trying to get to our final answer, we're going to be doing some work using double angle formulae, or rather the identities that go with them. So we've got our function x equals 6 sine squared 2y, and what they've asked us to find is dy by dx. All I'll be able to find is dx by dy, but then that's okay, I can just flip that upside down. Let's just do a quick reminder of how the chain rule works, because we're going to be using the chain rule on this one. If we've got y equals something of the format, let's do the one that they've got here, 6u squared, but where u is actually a function of x, then we're going to be using the idea that dy by dx is dy by du, differentiate that just as though it was a function, 12u in this case, but then multiplied by the differential of u, the differential of this function in here. Now I'm going to do that as I would under exam conditions, so I'm going to do it pretty quickly. I won't be writing this out each time, otherwise you'll see from the question that it gets too long to have a go at doing that. If you want more support on using the chain rule, you'll have to go back and look up for a different video on the channel. There'll be a how-to video on chain rule. But looking at this one then, a lot of my students prefer to write this as x equals 6 and then sine 2y squared, only when they're differentiating, and I haven't got a problem with it as long as they understand that that's not the way to write it. We should be writing it as sine squared 2y, but it just makes it a bit easier for this step now, that when I'm differentiating dx by dy, using that idea of the chain rule then, differentiate as 6u squared is going to be multiplied by the power, which will be 12, take 1 off the power, which will now be to the power of 1, we don't write that in, multiplied by du by dx, multiplied by the differential of what's in there. So the differential of sine would be cos 2y, but again we can use the chain rule again, it's cos 2y times by the differential of that bit there, which is 2, so in other words we get 2 cos 2y. Now, I've done that in a bit of a slow clunky way, so let's just go through that again at proper speed. If I had this function, then I'd say differentiating it as sine squared becomes 12 sine 2y times the differential of that, and the differential of sine 2y, I would expect you straight away to be able to say that's 2 cos 2y. By the time we're at exams, you should have that pretty much nailed down. Right, let's tidy that up then. That works out to be 24 sine 2y cos 2y. But then that's dx by dy, and what I want is dy by dx. So that's dx by dy. So dy by dx is just 1 over it. Flip it upside down. 24 sine 2y cos 2y. Now, have we got the answer? No. One of the things we notice about the answer is that everything's in terms of x's and my function is in terms of y's. So what that means is that I need to rearrange this to be able to get the sine 2y and the cos 2y in terms of x. So what I'm going to do just quickly over here is I'm going to say we know that cos squared x plus sine squared x is equal to 1, which means that cos squared x is 1 minus sine squared x, which means that cos x is the square root of 1 minus sine squared x. Now, I've only done that for you guys. I would ask all my students to actually learn that. Okay, it comes up so often that you should know cos in terms of sine squareds and sine in terms of cos squareds, because you know, in a vast majority of the actual exam questions, they're having an expectation that we see that. You'll see it as we go through and do the rest of this question then. Right, let's focus on the easier bit. Let's focus on sine 2y. I'm going to get sine 2y from this thing here. Okay, so if we've got, just rewrite it out again, if I've got that x is equal to 6 sine squared 2y, then x over 6 is equal to sine squared 2y. And so sine 2y is just the square root of x, which is the square root of x over 6. So I've replaced that one. And now, because of what we've just said previously over here, that cos x is root of 1 minus sine squared x. And again, let's write it in, because this is where I would actually write it in. I just write it straight in here, is the square root of 1 minus sine squared x. So in terms of actually my answer, I wouldn't have all of that. Okay, I'd just straight away jump to that bit there. The examiner will have no problem with you doing that. Cos 2y then is the square root of 1 minus sine squared 2y. So that's the square root of 1 minus sine squared 2y is up there, isn't it? 1 minus x over 6. So now, if I want to put this thing all together here, dy by dx is going to be equal to, so that's cos 2y, dy by dx is going to be equal to 1 over 24, the sine 2y, which is root of x over 6, excuse me, and the cos 2y, which is root of 1 minus x over 6. So all we've got to do with that now is to try and make that look like the answer that we had. 1 minus x over 6, again I'm just going to do it over here, but I just put this straight in. If we change that to that fraction like that, it's a standard thing to do, then I can cross multiply, and multiply those two things. What I'm going to get there then, if I do that, is 6 minus x all over 6. 6 times 1 is 6, 1 times x is x, all over 6 there. Again, 6 minus x over 6, I'll just put that bit straight in for my next line. So my next line is dy by dx is equal to 1 over 24. Let's just make it a bit neat here. Root x over 6, root 6 minus x over 6. So don't then keep that bit in. We're just trying to tidy this up to be in the same format as the answer is. Now here, because I've got those two square roots, I can write that as one single square root. So this is 1 over 24 root of x over 6 times 6 minus x over 6. Just make sure you're happy with what I've done there. All I've done is change those two to one single square root there. And then nearly at the answer now, guys. Probably the last step I'll do before I actually get to the answer here. 1 over 24, just multiply it out. So we've got root of x times 6 minus x is going to give me 6x minus x squared for the numerator. And this is really handy. 6 times 6 is 36 there. Okay, I've got a little bit of space. I'll do one extra line here. So that's 1 over, I can now take this root 36 out, can't I? So I'm going to have 24 over 6 times the square root of 6x minus x squared. And 24 over 6 works out to be equal to 4. So I get 1 over 4 root 6x minus x squared. And that is actually in the same format as what we wanted in the question there. It's in the same format with A being equal to 4 and B being equal to 6. But I'm just delighted it actually looks like the same style as the actual answer there. So I'm pretty sure I must have got that right as we're going through. So yeah, fair old amount of algebra in there, especially the fractions work, but you just need to get used to those. Question 7 of a P3 paper is not going to be that straightforward. But I hope all that makes sense. Apologies for anybody who saw the previous video where there was no sound to it. I've hopefully sorted that out with this one.